plot the points for number 5. So go ahead and do that on your own. We have -3, +2. We have -2, -1. We have -1, -2. We have 0, -1. And that should be indicated right away where we're at, because the only points that repeat would be a quadratic. Okay, so we're going to try to make an equation. So this is going to get a little fun. Okay, so we have a quadratic. And I'm going to get rid of my line. Actually, I'm going to undo this real quick, because the line's not very good. Okay. So we have a quadratic. Question is what is the equation? All right, so we're able to figure this out because we did stuff with movements, or transformations, I should say. So this is the equation, and if we had an equation, a parent function of it, it looks something like this, right? Wow, that is trippy. I've never used that before. Let me do this. The parent function starts at 0, 0. It goes up 1 over 1, and it goes something like this. Okay, so kind of weird that I just did that. Didn't know I could do that with drawing. So the question is, how much did the vertex shift over? Well, the vertex right here is -1, -2. So it shifted over left 1 and down 2. And because it goes up 1 over 1, up 1 over 1, it's not being vertically stretched or compressed, and it's not flipped. So that's all we need. So how do we write the equation? I'm going to use y equals. Well, if it's using left, you're actually going left. It's actually adding. And if it's down, it's still -2. So that would be the equation. Now you could go ahead and factor this, or not factor it, sorry, distribute it out. X plus 1 squared is saying x plus 1 and x plus 1, then you have -2. Just to make it faster, you have x squared. If you add the ones, you get the middle term, and if you multiply them, you get the last term. So it ends up being x squared plus 2x minus 1, but I don't need that, okay? So you don't need to make it or take it to that level. This would be just fine for me, okay? So number 6 is hard to do the way I would like to, because I don't have an emulator to put up my graphing calculator, so I can't show you how to do it in your graphing calculator, which is fine. You'll do stuff like this in Algebra 2, and Miss Holtzberry will teach you, so it'll be fine. All right, so let's talk about this. Let's figure out what kind of equation we have going on. Let's do that first, okay? So this is going up 1 every single time, so that's easy. Well, what's the difference between these? Remember, we're always going to try to figure out if it's linear first. So 720 minus 800 is obviously -80. And you do 640 minus 720, and you have -80. And if you do 572 minus 640, you get, oops, you get -68. Well, that's weird. And if we do 480 minus 752, you get -92. All right. This is data. So data is not always going to have a perfect slope, okay? So I'm just going to show you these points to prove to you that it is linear. And then we're going to try to write an equation. And we're actually going to do it kind of by hand, so this will be fun. So let's just show you. These are the points. If you can tell, it looks very linear. It's only a little bit off with our slope, and that's okay. So we're going to try to find an equation. Now the question is, why did I use 0, 1, 2, 3, and 4? Well, I find it really annoying to use 1999, 2000, 2001. It makes the table completely off to the right. It's hard to figure out. So what I'm saying is 1999 is now t equals 0. It's a start. So like 2001 is 2 years after 1999. Sorry, forgot the 9 there. So t is 2. So 2003 is 1, 2, 3, 4 years after. So what would 2008 be? Well, you're going to take 2008 minus 1999, and that gets you 9 years. So just keep in mind I used it a little different. So I made this 0, 1, 2, 3, and 4 on this Desmos. So when you write an equation, your first step is always to find the slope. And if you're looking at that, it kind of looks like it's straight on. But when we looked at our numbers over here, the numbers aren't consistent. So we have some choices. We can pick 2 random points kind of in the middle and go off and use that as our slope. Or we can say it's negative 80. Just for work, I am going to go ahead and use 2 points. So I'm going to use 2002, which is 3. It's the y value of 3. That's what I'm using. So 3 minus, oh, sorry, those are x values. So let's go back over this. It says t and v. T is like the x and v is like the y. So you're actually going to do the 572 minus 6 or 720. I just picked 2 random points. Sorry, I'm a little scatterbrained this morning. So I'm using those 2 points to make, I just picked those 2, or to make my slope, I just picked those 2 just because they're kind of in the middle of the data. So I'm going to do 572 minus 720, and then 2002 is represented by 3, and 2000 is represented by 1 in my table. So 752, I'm dyslexic. 572 minus 720 is negative 148, and then this is 2 on the bottom, so divide that by 2, and it's approximately a slope of negative 74. So if we're going to write the equation, I'm going to put that over here. We know the slope is negative 74x. Well, the last thing we have to figure out is the y-intercept, and the y-intercept is wherever the x value is 0. Well, this is the x value and it's 0. So the y-intercept right here is 0, 800. So you just add 800. So I'm going to show it to you and prove it to you. That's our equation, or our points. If I type in y equals negative 74x plus 800, it's pretty close. You can see it's a little off, okay? And it's closest to these 2 points because those are the 2 points we picked, okay? Some people pick the last point and the first point. That's fine too, okay? But we just did this by hand. So we want to figure out what this y value would be when the x value, I'll go back to the other page, is 9. So how do we do that? Well, we did it what we used to do. We used to plug it in. So we take y equals negative 74 times 9 plus 800. So 74 times 9 is, oh, creepy, 666, and the negative drops down. And if you take 800 minus that, you get 134. So it's saying what's the value in the computer? Well, it would be $134 in 2008. Okay, so that's the last example. If you have any questions, of course, get hold of me. We have a help session coming up, so just look out for that. All right, bye.